Hi, my name is You Jun. Today I will go through the tutorial 5 for my engineering mathematics 3. So the first question is to find the eigenvalues and the eigenvectors. So the matrix A is given. I let the A minus lambda I of the determinant is become 0. So solve it, like solve the determinant and get the final answer for lambda 1, lambda 2 and lambda 3, which is 2, -1 and -1. So this is the eigenvalues of the matrix A. And now I will solve the eigenvectors. For the eigenvectors, I let the Ax equals to lambda x for lambda equals to 2. So I rewrite the matrix and expand for their equation. X2 plus x3 equals to 2x1 for equation number 1. X1 plus x3 equals to 2x2 for equation number 2. X1 plus x2 equals to 2x3 for equation number 3. So from the equation number 2, I rewrite the equation to become a new equation, x3 equals to 2x2 minus x1, and set it as equation number 4. Then I substitute the equation number 4 into equation number 1 and get the final answer of x2 equals to x1. Then I repeat the same step for equation number 3. I rewrite it and become equation number 5. Then substitute the equation number 5 into the equation number 1 and solve it to get the final answer of x3 equals to x1. So the eigenvectors for lambda equals to 2 is x1 equals to 1, 1, 1. Then I solve for the lambda equals to -1, which is lambda 2 and lambda 3. So like the same, I rewrite the matrix and expand for their equation. X2 plus x3 equals to -x1, x1 plus x3 equals to -x2, x1 plus x2 equals to -x3 for equation 1, 2, and 3. So from the equation 1, I rewrite the equation to become equation 4 and substitute equation 4 into equation 2. Then I get the answer is no solution. As you can see, the x1 minus x1, then the x2 is minus -x2, so it will equals to 0 and 0. So this is no solution for the eigenvectors. So like the same, the equation number 3 also like the same is no solution. So there are no eigenvectors for the lambda 2 and lambda 3. Then I will go through the next question. The next question is also find the eigenvectors and eigenvalues for matrix A. So like the same, the determinant of A minus lambda I is equals to 0. Then I solve the equation here and get the final answer of lambda. Lambda 1 is equals to 4, lambda 2 is equals to 1, lambda 3 equals to 2. So for the eigenvectors, first is for the lambda 1 equals to 4. So I rewrite the matrix and get the equations of the matrix. 5x1 minus 6x2 plus x3 equals to 4x1, x1 plus x2 equals to 4x2, 3x1 plus x3 equals to 4x3 as equation 1, 2, and 3. So from the equation 2, I rewrite the equation to become x2 equals to 1/3 of x1. Then from the equation 3, I also rewrite the equation to get the x1 equals to x3. So the eigenvectors for x1 is equals to 1 over 3 and 1 for lambda equals to 4. So the next is lambda 2, which is 1. So like the same, I rewrite the matrix and expand the equations. So 5x1 minus 6x2 plus x3 equals to x1 for equation number 1. x1 plus x2 equals to x2 for equation number 2. x3 plus 3x1 plus x3 equals to x3 for equation number 3. So from the equation number 2, I can solve it. X1 is equal to 0. Then I substitute the x1 into the equation number 1 and get the x3 is equals to 6x2. So for the eigenvectors for x2 is equals to 0, 1, 6 for lambda equals to 1. So the last is lambda 3, which is equals to 2. So I, like the same, rewrite the matrix and expand the equation. 5x1 minus 6x2 plus x3 equals to 2x1 equals to equation 1. x1 plus x2 equals to x2 for equation number 2. 3x1 plus x3 equals to 2x3 for equation number 3. So from equation 2, I solve the equation and get x2 equals to 1 over 3x3. For equation number 3, like the same, I also solve the equation for x1 equals to 1 over 3x3. So the eigenvectors for x3 is equals to 1 over 3, 1 over 3, and 1 for lambda equals to 2. So now let us continue for the next question. So the next question also find the eigenvectors and eigenvalues. Like the same, the determinant c minus lambda I is equals to 0, and from the determinant solution here, to find the final value for lambda 1, lambda 2, and lambda 3. The lambda 1 is equals to 5, lambda 2 equals to negative 2, and lambda 3 equals to negative 1. So like the same, for we will find the eigenvectors for lambda 1 equals to 5. I rewrite the matrix and expand for their equations. For x1 plus 3x2 plus 2x3 equals to 5x1. Negative 2x1 minus 2x2 minus 2x3 equals to 5x2. Negative 3x1 minus 3x2 minus x3 equals to 5x3 for equation 1, 2, and 3. So from the equation number 2, I rewrite the equation to get the equation number 4, which is negative x1, negative x3, and equals to 3x2. Then I solve the equation 4 into the equation number 1. 4x1 minus x1 minus x3 plus 2x3 equals to 5x1. 3 equals to 5x1 minus 3x1 equals to 2x1. So I will get the final answer of x3 equals to 2x1. Then I substitute the x3 answer into the equation number 4 and get the final answer of x2 equals to negative x1. So for eigenvectors x1 equals to 1, negative 1, 2, for the lambda is equals to 5. So the next is lambda 2, which is negative 2. At the same, rewrite the matrix and expand the equation. 4x1 plus 3x2 plus 2x3 equals to negative 2x1. Negative 2x1 minus 2x2 minus 2x3 equals to negative 2x2. Negative 3x1 minus 3x2 minus x3 equals to negative 2x3 for equation 1, 2, and 3. From the equation 1, I rewrite the equation and get the equation number 4, which is negative 1 over 2 x2 minus 1 over 3 x3 equals to x1. Then I substitute the equation 4 into equation number 2 and get the final answer of x3 equals to 1.5 x2. Next, I substitute the x3 answer into the equation number 4 and get the x1 is equals to negative x2. So for the eigenvectors, the answer of eigenvectors x2 is equals to negative 1, 1, and 1.5 for the lambda equals to negative 2. The last is the lambda equals to negative 1. Same, rewrite the equation, rewrite the matrix and expand the equation. 4x1 plus 3x2 plus 2x3 equals to negative x1. Negative 2x1 minus x2 minus 2x3 equals to negative x2. Negative x1, negative 3x1 minus 3x2 minus x3 equals to negative x3. And I label them for the equation 1, 2, and 3. From the equation 1, I rewrite the equation to get the equation number 4, which is negative 3 over 5 x2 minus 2 over 5 x3 equals to x1. Then I substitute the equation number 4 into equation number 2 and get the final answer of x2 equals to x3. Next, I substitute back to the equation number 4 by the x2 and get the final answer of x1 equals to negative x3. So for the answer of the eigenvectors x3 is equals to negative 1, 1, and 1. For the lambda is equals to negative 1. So for the next equation is to identify the equation is vector or not. So the A is a vector. This is because the equation A have the arrow in the top there. So this is magnitude values. So for the equation B, which is not vector, and for the equation 3 also the not vector. For the equation for D, which is C equals to 2i, this is a vector. This is because the I is like the x in the I is the what, the unknown for the vector, represent for the vector, and the equation E is a non-vector. And lastly, for equation F, it is a vector. This is because they have I and K. Yeah, this I and K are the unknowns for the vector. So that's all for tutorial 5. Thank you.